So tomorrow we're going to be talking about identifying slope in real world problems and in all three forms. All three forms meaning graph, table, and then function rule. So if we look at this first problem, it says a small business purchased a van to handle its delivery orders. The graph below shows the value of this van over a period of time. How much does the van or the view of the van decrease per year? That's supposed to be value. Do apologize, guys. This is supposed to be value. All right. So if we look at this graph, note that at the beginning when it's purchased for $16,000. So we're going to put a point there. How do I know it's when it's first purchased? Because down here represents the years, how old it is, and here represents the value. So right here on this y-axis, the year is 0, meaning when it was bought. All right, and it's hard to tell after 1 year what's going on here, right? Because it's kind of in between some things. So it's hard to predict. So we're not going to use that point. All right. But if we come down here to about after 5 years, we can clearly see that the value is $8,000. So if we're to say how much is decreasing each year, then we need to basically find our rate of change or slope. So to go from the first point to this point, all right, remember this is our change in y, here's our change in x, and basically, remember, we need to find change in y over change in x to find our rate of change per year. All right, so basically to find the slope. All right, so we go down here, 8,000, so that's negative 8,000. And then here we go right 5 years. So this becomes negative 8,000 divided by 5. And I'm just pulling up my calculator here. All right, and it appears that each year the value of the van goes down negative $1,600. So $1,600 each year, the value goes down. And we've answered the question because it says, how much does the value of the van decrease per year? And here's our answer. All right. Says the line segment on the graph shows the altitude of a landing airplane from the time its wheels are lowered to the time it touches the ground. All right. So our y-axis is altitude while our x-axis is time. And it appears that the wheels are initially lowered when the plane is 1,500 feet in the air. Says which of the following best describes the slope, keyword slope, of the line segment? Well, we're going to do the same thing we did in problem number 1. We need to find 2 points. It's pretty easy to see the initial, which is 1,500. All right. But after about 60 seconds, we can clearly see that the height is 1,000. All right, we can clearly see the height is 1,000. Notice we're in seconds. So 60 seconds is a minute. And in 60 seconds, it looks like the altitude decreases by 500. So the change in y is negative 500. Our change in x appears to be 60 seconds. So that's negative 500 divided by 60. Right? Because remember, we're finding the slope. All right. And let's see what we come up with. Negative 8.33 repeating. So we're going to leave it just like this. And that's our slope. So we're going to kind of round here to just say negative 8. But when we read these answer choices, which one works? Is it the plane descends about 1 foot per 8 seconds? The plane descends about 8 feet per second? Or the plane descends about 1 foot per 2 seconds? Or the plane descends about 2 feet per 1 second? All right, people, tell me your answer and bring it to class. The rest of these, we're going to complete in class as practice because we're going to talk about our rate of change. We're going to talk about the y-intercept, how to write an equation in slope-intercept form, and so on and so forth. So if you would like, take a screenshot of this, practice it, and bring it to class so you could be ahead of the game. Have a good one, guys.